Hello, and this is our lesson video about simplifying radicals. Our learning target is to completely simplify radicals, and we've got quite a few examples, so let's just start buzzing through them. The first one, remember, this is a square root house. So we talked about this before when we talked about the power over root kind of stuff. That root is understood to be a 2, so that tells me I'm looking for a set of pairs. And to simplify, what we do is we factor tree, and we're going to get 3 and 25. I just decided to go with that pair of 75. 25 breaks down to 5 and 5. So I'm looking for a pair of something. So I have a pair of 5s. I have 2 5s. So what that means, it takes 2 of them for 1 to go out and play. So a 5 is going to come out. Okay, because I have 1 set, so 1 5 comes out. But I had this 3 that was left over. Okay, what are we going to do about that poor guy? He doesn't get to go outside and play. He has to stay in the house, more specifically inside the square root house. So this would be simplified radical for the square root of 75. Now, let's break down 162. Rule of thumb that I usually do, if it's even, I just go with 2 and whatever the other factor is. So we've got 2 and 81. Obviously, I can't divide by 2 anymore, so I'm going to break 81 down to 9 and 9. And then I'm break these 9s into 3. So remember, you're breaking it down in factors that multiply to the number above. So based on this little 4, I need quadruples. So I need a set of 4 things. So lucky for me, I have 4 3s. So because I had a set of 3s, a 3 comes out. But what got left behind? Aw, the 2. He got left behind. He has to stay in the house. He doesn't get to go out and play. So under the 4th root house, we keep a 2. Oops, that's the same slide. Here we go. Here's some new ones. I've got a cube root. All right, so I'm looking for triplets when I do a factor tree. Now here's a rule of thumb. Whenever your number ends in a 5 or a 0, you could always start with a factor of 5. So let me use my calculator real quick. So 5 and 75. And we did 75 earlier, 3 and 25, so I think I'll go with that pair. Or I could have done 5 again. And then this is going to break down to 5 and 5. Now I need 3, I need triplets, so it's going to be kind of a weird shape, but here are my triplets in 5s. So there's my set of 5s. So that means a 5 comes out, but what's left over? Be careful, we used up 25 already. What's left over is this 3. He has to go back inside, poor guy. He has to go back into the cube root house. Okay, so there we simplified example C. Example D. Again, here's an even one, so I'm going to start with 2, and I believe that's 64. Yep. All right, and since 64 is even, I'm just going to keep going with 2s. So 2 and 32, 2 and 16, oh my goodness, 2 and 8, holy cats, 2 and 4, 2 and 2. Whoa, mama, there's a bunch of 2s here. Yikes. Okay, how many do I need, though, to form a set? Based on my little index, I need 5. So, by golly, I definitely have 5 of them. Okay, so there's my 1 set. Woo! So a 2 comes out. But what got left behind? What has to stay in the house? This guy and this guy. So inside our 5th root house, okay, those 2 2s have to go back in. But make sure you multiply whatever goes back in. So 2 times 2 would actually be a 4. Alrighty, cool beans. What else we got up? Oh, cube root of 216. This might look familiar. We've dealt with this before. I can at least divide by a 2 since 216 is even. And I think I'm just going to keep going with 2s. So 2 and 54. 2 and 27. Oh, but I can't divide out of 2 anymore, so I'm going to go with a 3. So let's go with 3 and 9. And then 3 and 3. So based on my little index of 3, I'm looking for sets of 3. I'm looking for triplets. So So what do I have triplets of? Oh, I got triplets of 2s. And oh, I got triplets of 3s. So what does that mean? That means from the set of 2s, a 2 comes out. From the set of 3s, a 3 comes out. But holy cats, 2 numbers coming out. What do we do with them? We multiply them. Is there anything left to go back in the house? Double check. All these other numbers, we broke them down. So I used up everything. My house is actually going to go away. This is a perfect cube root, and the answer is a 6. Okay, so that can happen sometimes. Your house might go away. All right. Whoa, this guy looks big. I guess let's go with a 5. We might end up with a mammoth factor tree, but that's okay. And then I'm gonna, since he's even now, I'm gonna go with 2s. And let's see what happens. So yes, I'm doing this factor tree with you as I'm going. Holy smokes, this guy is big. We're just gonna keep going with 2s. Ah. Why did I pick such a big number, right? Almost there. Whew. Okay, that was a workout. That'll make you start a sweat, huh? So because I've got this index of 4, I need quadruples. So, whoa, I got a bunch of stuff happening. So, yeah, there's a set of 4. Do I have 4s of anything else? 3, 2, 2, 5, dag-nabbit, that's it. So after all of that, just a stinking 2 comes out. What stays under your 4th root house? Well, what's left over? 5, 2, 2, and a 3. Yikes! So just remember, make sure that you multiply all of that stuff back together before you put it in. So that looks like that would be 60. Okay, so 2 times the 4th root of 60. And just so it looks better, let me get blue ink so it all looks like it's the answer. There we go. All right, cool beans. What's up next? Oh, what about when we have variables under our radicals? Is it any different? No, actually, it's not. So check this out. It's pretty cool. Yeah. This is a square root, so there's a 2 there. So when I do my factor tree, I got 5 and 5. I got a pair of 5s. But don't forget about these x's. Here's what I like to think about. X squared, that means I've got x times x. So what all do I have pairs of based on my little index? I got a pair of 5s and I got a pair of x's. So what does that mean? A 5 comes out and an x comes out. Since there's nothing left, my square root house goes away and 5x is my answer. Whoa, who would have thunk it, right? Pretty cool. Okay, let's break down the 12. Again, there's a little 2 there, so I'm looking for pairs. So I'm going to go with 3 and 4 and 2 and 2. And I've got 3 x's this time because I'm dealing with x cubed. Now, what do I have pairs of? Well, I got a pair of 2s. I got a pair of x's. Any other pairs? I've got a 3 and an x left. No. So, a 2 and an x will come out. What goes back in the house? What was left over, left behind? This 3 and this x. So under our square root house, we would have 3x. Nice, getting jiggy with it. All right. Few more here. No number, just have 5 x's. That's interesting. But based on my little index, I'm looking for sets of 4. Well, hey, I definitely have 4 x's. So because I've got a set, an x will come out, but I had something left over. I had that guy left over. So he has to go back in. Poor guy got left out. Now here's where they get fun. Okay, we've got numbers and letters and whoa, we've got 2 variables. Yikes! Don't let it scare you though. It's just the same exact thing, okay? So factor tree 54, I'm gonna go with 2 and 27, and then obviously 3 and 9, and then 3 and 3. I've got 3 x's, and I've got 5 y's. All right, so I'm looking for sets of 3 based on my index. So I'm looking for triplets. I've got triplets of 3s. I had just enough x's. And oh yeah, there's a set of y's. So for each set, remember, one of those comes out. So a 3 comes outside, an x comes outside, and a y. One from each set. And then whatever's left over has to go back under the cube root house. So I had a 2 left over. I already used up the 9 and the 27, and I've got 2 y's left over. So under the cube root house, I've got a 2 and 2 y's, so I'm going to condense that to y squared. Okay, and there'd be our simplified radical. Nice. All right, one more. Here we go. Factor tree. Oh yeah. 128. Break it down. 2 and 64, and then 2 and 32, and then I feel like I've done this before. Oh, 2 and 8, 2 and 4. Okay, 2 and 2. So I've got, oh my gosh, I've got a bunch of 2's. Okay, I need 5 of them to form a set, but I guess let me draw out my letters. I've got 6 x's. Yeah. And I've got, oh my gosh, 7 y's. Oops, I need one more. Okay. I need 5 to make a set. So I definitely have enough 2's. Ooh. I definitely have enough x's. And I definitely have enough y's. All right. So however many sets, from each set, one of those numbers comes out. So a 2 is going to come out. Let's write in purple. So a 2 will come out, an x will come out, and a y will come out. That's one from each set that I had. Now what was left over? A 2, an x, and 2 y's. So in the 5th root house, all that stuff has to go back in. So the 2 2's we'd multiply to 4. My single x, and then my 2 y's I'd write as y squared. And bada boom, bada bing, there it is. We are all done. So take a breather, okay? Simplifying radicals, they aren't that bad. Like our learning target says, we can completely simplify them. We'll continue to do this in class. I'm going to give you a couple preview problems, all right? Even though you'll probably be doing these in class, here they are. Okay, so here they are. Just complete these. Like I said, we'll probably be doing this in class unless you're absent or something. So just complete these preview problems and then show me when you're done, and I'll give you your worksheet to start in class assignments. All right, keep learning and have fun, guys.